This video is a continuation of the data notebook, and we'll be discussing plotting using the ggplot2 package. The plotting functions we've looked at so far have been part of the basic R installation, and there are a number of plotting packages out there for use, and each vary greatly in the features offered and their ease of use. One that is quite popular is ggplot2, which we installed as part of Tidyverse. ggplot2 is an open source implementation of the grammar of graphics, which allows us to describe components of a graphic concisely and specifically. If you wish to read Hadley Wickham's paper on this, I've included a link to it here in the first paragraph. This paper not only describes the grammar, but provides a number of examples as well. And for more examples, the last two links here in the first paragraph are to the R Statistics website. And on this website, you can find tutorials and code examples for creating some really nice visualizations. In fact, the last example I'm going to give you here is one of the code samples from the top 50 ggplot2 visualizations. We're actually going to go through that and build the figure one step at a time. To get started on that, as a reminder, for these plots, you're going to need to ensure that ggplot2 is loaded. And also, do try to keep all of your library calls at the top of your scripts, meaning run those first. Also, before we get started, in the text here, there are some additional references, including an online book, ggplot2 Elegant Graphics for Data Analysis by Hadley Wickham, Daniel Navarro, and Thomas Lynn Peterson. This book basically covers all aspects of ggplot2. And then the other three links here are about themes that we use in ggplot2. Now, themes are used in ggplot2 to control the visual appearance of your plots. Basically, this allows us to easily set colors and fonts and line thicknesses and a bunch of other settings all in one place so that we can reuse them in all of our plots. This is a nice feature, especially if you're creating publication quality figures and you want them to appear consistent throughout. So to set a theme, which is optional, we can use the theme set function, and we're going to use one of the built-in themes, Theme Classic. Do check out the links above for some other themes you can use, and at the very end of this example, we will modify the theme to show you how the figure can change just with one call to this function. The next thing that we may want to do is set the output size for our figure in Jupyter Notebook. Now, this may work in other contexts, but typically when you write a figure to a file, at that time, you will specify the resolution of the size of the figure. And when displaying figures in the console, there's typically a resizable interactive window that opens. In Jupyter Notebook, however, the figure size is fixed in the output portion of our code block. So we may optionally set the size here using the options function. The options function lets us set values for a number of globally defined attributes. Check out help options or run the options function without arguments for more information on what's available there. In this case, however, for the width and height of our figures, we're going to use the repr or repr.plot.width and repr.plot.height, and then give some values. So more specifically, I'm going to write options, and then for the arguments, we'll type repr.plot.width, and I'll say 10 here for the value. And then for the second argument, it'll be repr.plot.height, and we'll give it a value 6. Now, feel free to play with these values, but we're actually not going to see their effect until actually we run the next code block where we actually create a plot and then display it. So at this point, we have a theme, which contains some display properties for our figures. We've also set the width and height for the figure when it's displayed in Jupyter Notebook. And now, before we can create a plot, we need some data. So let us load the MPG dataset, which is going to contain the fuel economy and other data for several popular cars. And then we're going to output the structure of the dataset just for reference. And now we can finally use the ggplot function to create our plot object. The first argument to this function is going to be our dataset, MPG. Now notice I'm passing the entire dataset MPG and not a subset of its columns like we did in previous examples. The reason for this is that the next argument, and then also in subsequent function calls, we're going to provide mappings from the data inside this data structure to graphical components that will be displayed in our figure. So the next argument is what's called an aesthetic mapping, AES. And an aesthetic mapping describes how variables in the dataset are mapped to visual properties. So let's say that we wanted the city miles per gallon for each vehicle to appear along our x-axis. we would define a mapping from x to the variable city in the dataset by creating a mapping AES and using x equals city, where city is the name of the column in the MPG dataset. Notice that when we specified the city variable, we didn't have to specify that this was from the MPG dataset. And the reason for this is that the AES mapping, or the aesthetic mapping, is going to be applied to the MPG dataset for us by the ggplot function. All access or subsetting that's needed will be handled internally by this function. And now with only our data set and this one mapping to the x-axis, we can actually display our ggplot object. We see that we get a white background with the x and y axes denoted with a thin black line. Also along the bottom, we see that the label city has been applied, and there is an appropriately chosen range of x values. The colors and font come from the theme that we've chosen, and if you were to modify the theme and redisplay the plot, you'd see the changes of colors and fonts and so forth. The x-axis min and max, along with the label, actually all come from the aesthetic mapping. It uses the actual data to determine the range of the values that should be used here. And lastly, you may have noticed that we didn't plot anything, which makes sense since we've only specified a mapping for the x-axis. So we're going to fix that now. We're going to define a new variable h to hold our new plot, and we're going to start with our current plot g. Now with the grammar of graphics, we're going to literally add new graphical components to our plot using the plus operator. The new component we're going to add will be a kernel density estimate, or a smooth version of the histogram. To compute this, we're going to use the geom_density function, which is actually very similar to the density function we used in our histogram example above, except that this one is designed to work with aesthetic mappings. So we're going to use this function to draw the kernel density estimate, but instead of doing so for every car in the dataset, we're going to use a factor to group the cars by the number of cylinders in their engines. And by doing so, we can compare the city miles per gallon for each type of engine. Recall that our x-axis is the city miles per gallon. So at this point, with no parameters, if we were to simply output our figure, we would actually get the density for all vehicles. But since I said we wanted to group these by the number of cylinders, we're going to pass an aesthetic mapping and use the fill argument that it provides. And we will set this fill argument to be the variable cyl, or cylinder, from the dataset. If you recall from the output of the structure function, the cylinder column is of type int and not factor as we would like. So we're going to explicitly convert that column to a factor now. If we look at the output, we now have the densities for the 4 engine types shown, including a legend on the right-hand side that tells us which color maps to which number of cylinders, or which engine type. But in the figure, each of these densities overlaps, and we can't actually see what's going on here. So to fix this, we can tell the geom density function to make these slightly transparent using the alpha argument. The alpha argument takes values between 0, meaning fully transparent, and 1, meaning opaque or solid. So we're going to give it a value of 0.8, as that should allow us to slightly see through each one and hopefully see what's going on in all of the densities. So the plot's starting to look pretty good, but there's no title, and the labels that we have come directly from the code, and so they're not really publication quality. We can add labels using the labs function. Once again, we're going to use the plus operator. And for the labs function, the first argument I'm going to give is the title argument. And for this, we'll simply just specify this as a density plot. For the next argument, I'm going to specify the subtitle and say city mileage grouped by number of cylinders. Then I'm going to add a caption in which I'm going to put the source data as MPG. Then for the X label, I'm going to put city mileage as opposed to the column label that was automatically applied. Similarly, for the Y value, I'm going to put density. This I'm capitalizing the D. The last argument I'm going to use is fill, which will allow me to assign the name of the legend on the right-hand side. And for this, I'm going to put number of cylinders using the pound sign for number. And now this is starting to look a bit more reasonable. And there are lots and lots of options. But before we wrap this up, I am going to show you one more thing with regards to the theme. If we call the theme set function again, this time I'm going to pass a different theme dark, and then we redraw our figure, we can see that the background color has changed. There are now grid lines. And really, we can give our figures some very different looks and feels without a lot of effort. In this video, we looked at a few built-in functions for plotting in R. We also walked through an example using ggplot2 in the Grammar of Graphics. And in this last section here, I've given you some additional links to other plotting packages. Many of these are specialized packages for dealing with things like web applications or maps or even networks. So depending on your needs, you may wish to check out some of these as well.